All right, guys, this is section 1.1 that we're going to work through for this semester. We're going to focus on trig this semester. So a lot of this is actually going to be review. But if you look at this picture here, we're going to use three different names for all these right triangles. We're going to call the hypotenuse is always the piece that is across from the right angle. And then the opposite and the adjacent are going to change a little bit depending on where you're standing. So for example, if we're standing right here where this T is, then as we walk across the triangle, that's the opposite, and then the one right next to us is the adjacent. In terms of understanding some of these relationships are relationships hopefully that you kind of already have memorized, but remember sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. And then the three on the right side are basically just the reciprocals of those. So cosecant is hypotenuse over opposite, secant is hypotenuse over adjacent, and cotangent is adjacent over opposite. One thing to keep in mind is that the tangent ratio is really the rate of change of the hypotenuse. So when we talk about rise over run, that's what that's going to show us with the opposite over the hypotenuse. Again, the way that we say these, sine is actually said S-I-N-E. We're fine abbreviating it just S-I-N, and that's the button you look for on your calculator. We have cosine, tangent, and then the reciprocals are cosecant, secant, and cotangent. One way that I sort of think of these, and it's not a great way, but I think it kind of works, it seems like these two should go together, sine and secant, because they both start with S's, but they actually don't. So you sort of have to tell your brain that sine and secant should go together, but they don't actually. And then the other thing is the two that start with co. I feel like they should go together, but they don't actually. All right, down here, we're given a triangle, and then we're asked to find the value of cosine of this angle. So what that tells us is we are going to stand right there, and then remember the cosine is asking us to find the adjacent over the hypotenuse. So I know that the adjacent is right here, right next to us, and then hypotenuse is over here. So that means that cosine of alpha equals 15 over 17. Next one, we're still going to be standing right here, and so I think it's best to label this. This is our hypotenuse. We know this is our opposite, and we know that this is our adjacent. So the sine is going to be the opposite over the hypotenuse, which is 4 over 5. Now, the one thing that's really nice about that tells us that the cosecant is going to be the reciprocal, so 5 over 4. Next, we can do cosine. Cosine is adjacent over hypotenuse, so 3 over 5. And then that also tells us that secant is 5 over 3. Finally, tangent is opposite over adjacent, so that's 4 over 3, which means that cotangent is 3 over 4. Okay, some special relationships that we need to know. We've got these special right triangles. The first one, the easiest one we'll look at here on the right, is the 45, 45, 90. Remember, the two legs are just x, or sometimes you'll see me write 1, and then the hypotenuse is that value times the square root of 2. The easiest thing to remember is as you're going from a leg to a hypotenuse, you want to multiply, you want to get bigger because the hypotenuse is always biggest, and then to go from the hypotenuse back to the leg, we're always going to divide. Now down here, or over here with the 30, 60, 90, one thing that I really pay attention to is this short leg. I think that getting to that short leg is really important. So obviously to go from long to short, you're going to divide. To go from hypotenuse to short, you're going to divide. From long to short you're going to divide. Now, one way that I remember this right here is the square root of 3. Now, this is obviously just 2, the whole number 2, but then I always think to myself the square root of 4 is equal to 2. So I know that the hypotenuse needs to be the biggest side. So the square root of 4 obviously is bigger than the square root of 3. So that's how I know to label these. All right. This middle part of the notes, go ahead and leave that blank. We'll do that in class together. I kind of want to start talking about identities and proving things together. But then we are just going to take a 30, 60, 90 triangle. So this is 30, this is 60. That means that we're going to stand right there. This is our hypotenuse. This is the adjacent. This is the opposite. Now, this adjacent ends up being the smallest side, so we're going to go ahead and label that x. The long is 2x. Sorry, the hypotenuse is 2x. And then the opposite is x times the square root of 3. Now we're going to go through and just like the other examples, so sine, we are looking for opposite over hypotenuse. So x times the square root of 2 over 2x, x times the square root of 3 over 2x. Now those x's are going to cancel, and so we're going to be left with the square root of 3 over 2. Now again, nice little shortcut here. We know that cosecant is now going to be 2 over the square root of 3. We do need to rationalize that denominator. So multiply by the square root of 3 top and bottom. That gives us 2 square root of 3 over 3. Cosine is going to be adjacent over hypotenuse, and then those x's will divide out, and we're just left with 1/2. That means the secant is just 2. Finally, tangent, opposite over adjacent. If we divide those out, we get the square root of 3. Now cotangent, be careful here. It's 1 over the square root of 3, but we're not okay with that, so we're going to rationalize and get the square root of 3 over 3. Those are things that you're going to eventually have memorized with the special types of triangles, the 30, 60, 90, and also the 45, 45, 90, but we'll talk about those a little bit more later on. All right, so down here we have a triangle, and we're trying to find the missing sides. So let's just go ahead and stand right here at the 30 degree. That's going to make the C value, there's our hypotenuse. This is opposite, this is adjacent. Now remember, we talked that the short side, which is across from the 30, is always x. The hypotenuse is 2x, and the adjacent is x times the square root of 3. So this one's actually really easy. It's actually easier to use these special right triangles to go from our short to our hypotenuse. We're just going to multiply 7 times 2, and we're going to get 14. So that means that C equals 14. Same thing to go from short to long. Obviously, we're going to multiply because we want to get a larger number. So we're going to take 7 times the square root of 3, and that's just 7 square root of 3, which means that A is equal to 7 square root of 3. Now, we could have done, eventually we could have done Pythagorean theorem. We could have used some different ideas here. But honestly, because this is a 30, 60, 90, that's the easiest way to do this one. The last thing for today is angles of elevation and angles of depression. Now, one thing that you always want to notice or pay attention to, these angles are always from the horizon. IB loves to ask types of questions like this, so you will see an angle of elevation, angle of depression eventually on your papers. And if you remember back to geometry, the angle of elevation from this sort of horizontal area up here is actually the same as the angle of elevation from the ground. Now, IB does get a little picky. They want your pictures to be correct, but in terms of doing the math, I think there's a pretty easy way to figure that out. And then you can just kind of make sure that your picture makes sense. So for this example, we're trying to find the height of a tree. So we're going to put our variable there because that's what we're looking for. Person walks to a point 30 feet from the base of the tree. So 30 is going to be right there. And then there are different tools that you can measure and this is 57 degrees. So it says a line of sight to the top of the tree and the ground. That's another way to ask for the angle of elevation. Now we are standing right there. There's our hypotenuse, there's our opposite, there's our adjacent. From those, we are really concerned about the opposite and the adjacent. So tangent of 57 is going to be x over 30. To solve this equation, we're going to multiply both sides by 30 and get 30 times the tangent of 57. Now you're going to use your calculator. Please be sure that it is in degrees. And if you type in 30 times tan of 57, hit equals, it should round to 46.2. So that's going to be the end of section 1.1, right triangle trigonometry.